Okay, so as I was saying before, if your line of rotation is below it, you're going to have addition. If it's above it, it's subtraction. If it's to the right, it's subtraction. If it's to the left, it's addition. And so what do I mean by that? It's how it affects the radius of the problem. So these boundaries of your integration are corresponding to the function height, okay? And so what are you going to manipulate on these problems when it comes to the shell method? You're going to manipulate the radius. And the same thing for the disk method. You're going to manipulate the radius of the problem. And so how are we going to manipulate the radius of this problem? Well, for this one right here, this is off to the right, so it's going to be subtraction. So I'm going to say that's 5 minus x, okay? Because the radius is going to begin at 5, and it's going to contract inwards until I get to a radius of 3, okay? Now, and you can just say 5 minus x, okay? And then, but on this one, and another way to think about this is it's 5, and you've got a little bit of missing distance right here. This is your x distance, okay? So another way to think about it. But if your line of rotation is off to the left, you know, this is a distance off the left. So we have this distance right here, which is 3. And then we're adding that distance right there, which is our x. And so this is how you would manipulate the radius depending on the type of problem that you had. I mean, depending on your line of rotation. So just remember, if it's to the right, whatever point, if it's rotated around 7 minus x, okay? Now, if it's rotated around -4, okay, that's to the left. And so what would that be? That would be 4 plus x, okay? And so whenever you're doing things to the left, you're adding in some extra radius to this x direction that's already being built so that your radius begins at 3 and then goes out to 5, okay? But on this one, since it's over to the right, this is going to be a contraction of the radius. And so it's going to begin at 5. And so when I plug in my boundary of 0, it begins at 5. And then when I plug in my boundary of 2, I get 5 minus 2, which is 3. And so, but you want your function height to always correspond to those two boundaries, 0 and 2. And so your function height needs to be corresponding to those boundaries. And a similar type of manipulation is done for rotations around the disk method, okay? Now, the disk method can be explained in a couple different ways, all right? But if I look at the disk method, okay? All right, so remember, when you do the disk method around the y-axis or these lines of x equals 5 or anything like that, then you're going to have to integrate with respect to y. So that's why the boundaries on this one okay, on the shell method, your boundaries are from 0 to 2 because you're integrating in the x direction. But when you're doing the disk method, we're pushing those disks upwards. And since we're pushing those disks upwards, we have to go from 0 to 4. Okay? And so then you would say, this right here is your radius. This is what you're dealing with. Okay? And what is this root y, x which equals root y? That's really that distance right there. What are you doing? You're subtracting that extra distance out. So what happens when we plug our boundaries into that? If I plug 0 into that, I get a radius of 5. Now, if I plug 4 into that, I get 5 minus the square root of 4, or 5 minus 2, which is 3. So that's giving me this whole thing right here. It's giving me the interior too. So when you do this with the shell method, your radius actually just begins at 3 and expands outwards. You got to say for the disk method, remember, whenever you're talking about the disk method, I mean the shell method, it's the height of the function that is building your volume, okay? Now with the disk method, it's you want to look at the radius and say it's the area of the circle that is actually creating the volume that you're dealing with. So on this one, this radius, this line right here, it's not building anything. It's this line right here, Okay, it's the height of the function. But on this one right here, we have this radius going all the way out. That is forming the entire interior because it's that entire line that is being rotated. So we have to consider that since we're building the entire radius, we're getting this full thing right here. So then we have to say, all right, now I need to subtract out that inner cylinder that wasn't a part of the picture. And so for this one, where'd you go? So a comparison between the two methods when it comes to a line that's off to the right is that with the disk method, you're just pushing all the way up from 0 to 3, and then you have to say, all right, now I got to subtract out the interior, okay? But for the shell method, what's it doing? It's an integration in the x direction, okay? And so in that one, we're imagining that our shells are beginning with a radius of 5 and then contracting inwards until we get a radius of 3. Now, since our radius only went from 5 to 3, we don't have to worry about the radius of all that interior stuff because the radius is not building it. The function height is actually what's doing the job. So, and you might see this written in slightly different ways. Some people like to, when they do the disk method, some people will write that as the square root of y minus 5. And what they're doing when they do that, they're saying, okay, shift everybody over, okay? And so they're doing a shift in that case. But you got to realize at the same time, this thing's getting squared. So 5 minus root y and root y minus 5, they're the same thing because it's getting squared. So you might see it formulated in a slightly different way. But the reason that I always write it like this is because for the shell method, it's whatever point minus that x. That's going to be your radius of the problem. And so if you can just write it in the same way when dealing with the disk method, then why not? Okay. And then, so if it's off to the right, you're going to do subtraction. Just take whatever point you're rotating and subtract out that, and you're manipulating the radius on both of these. Okay. And then if it's off to the left, well, then what are you doing? You're just going to add. Okay. To write 3 plus x. And then if this was done with a disk method, this problem right here, what would we have to do? We'd have to take a big outer cylinder, and then we'd have to subtract out this kind of bowl thing in the middle. But you could still say, well, and it'd be an integration with respect to y. So instead of being 3 minus root y, it would just be 3 plus root y. And so that's what I mean. And if it's below, just going to add that extra distance in. And if it is above it, you're going to do subtraction. Okay? So I'm going to go ahead and write this down. leave that as a statement. Okay, so that's your general rule of thumb when it comes to rotations about lines that is not an axis. Okay, and when I'm saying subtraction or addition, what am I telling you to do? What am I you adding or subtracting? You're manipulating the radius. Okay, so that's why I'm going to leave that there for right now while I say that. So in dealing with a shell method, okay, you have 2 pi RH. You're going to manipulate the radius through addition or subtraction, okay? Now, when you have a disk method, okay, what is it? Pi r squared. So in that case, what are you doing the addition or subtraction on? You're doing it on that r that's inside of the square. So you're manipulating the pi r squared. But anytime you think about this type of rotation, you want to think about, I have to change the radius of what I am talking about, okay?